Good morning to all. My name is S. Irfan. I am from ECE section. Today my topic is quantum free electron theory from engineering physics. Quantum free electron theory was proposed by Sommerfeld in 1928. It overcomes many of the drawbacks of classical theory. Sommerfeld explained by choosing Fermi-Dirac statistics instead of Maxwell-Boltzmann statistics. He developed this theory by applying the principles of principal mechanics. Assumptions: valence electrons move freely in a constant potential within the boundaries of metal and is prevented from escaping the metal at the boundaries in high potential. Hence, the electrons is trapped in a potential well. The distribution of the electrons in various allowed energy levels occur as per Pauli's exclusive principle. The attraction between free electrons and lattice ions and the repulsion between the electrons themselves are ignored. This distribution of the energy among the free electrons is according to Fermi-Dirac statistics. The energy values of the free electrons are quantized. To find the possible energy values of the electron, Schrödinger time-independent equation is applied. Quantum free electron theory, electrical conductivity. To overcome the drawbacks of classical free electron theory, Sommerfeld proposed quantum free electron theory. He treated electron as a quantum particle. The electron follows the principle of quantum theory and Pauli's exclusive principle. Under this, the velocity of free electrons are plotted in the velocity space with dots in figure from the origin of sphere. The maximum velocity of electrons at highest occupied level, Fermi level, is also known as the Fermi velocity Vf and is represented by the radius of the Fermi sphere. In the absence of the electric field, these velocities cancel each other and not velocity in all directions in zero. If the electric field E is applied along x direction, then the electrons in the sphere experiences a force along x direction. Only the electrons present near the surface can occupy the higher energy levels as a result, as shown in the figure. The relation between the momentum p and wave vector is given by p is equals to h cut k, mv is equals to h cut k, nu is equals to h cut k by m. This is equation 1. Differentiating the above equation with respect to 2, we get a is equals to dv by dt is equals to h cut dt by m dt. Force on the electron in the applied electric field E is given by F is equals to E into MA is equals to small e into capital E. M into h cut dk by m dt is equals to small e into capital E. Mm cancel. H dk h cut dk by dt is equals to small e into capital E. Dk is equals to small e into capital E dt by h cut. Integrating the above equation, we get k of t minus k of 0 is equals to small e into capital E into t by h cut. Let tau f and the lambda f are the mean collision time and mean free path of the electron at Fermi surface. Then tau f is equals to lambda f by Vf on Fermi surface. T is equals to tau f and kt minus k0 is equals to delta k. Then delta k is equals to small e into capital E into tau f by h cut. Small e into capital E into lambda f by h cut into Ef. This is equation 2. The current density J is equals to Ne delta V, where delta V is the velocity, is the change in velocity from equation 1. Delta V is equals to h cut delta k by m. J is equals to Ne h cut delta k by m, where m is the effective mass of the electron. Substitute the value of the delta k from equation 2. Then we get J is equals to Ne h cut into E into capital E into lambda f by h cut into Vf by m is equals to n e square by tau e by m into E. But J is equals to sigma e. Comparing the above equation, we get sigma is equals to n e square tau f by m. The above equation represents electrical conductivity. Merits of the quantum free electron theory. It successfully explains the electrical and thermal conductivity of metals. It explains the thermonic phenomena. It explains temperature dependence of conductivity of metals. It explains the specific heat of metals. It explains the magnetic susceptibility of metals. It explains the photoelectric effect, Compton effect, and black body radiation, etc. It gives the correct mathematical expression for the thermal conductivity of metals. Demerits. It is unable to explain the metallic properties exhibited by only certain crystals. It is unable to explain why atomic arrays in metal crystals should prefer certain structures only. This theory fails to distinguish between metal, semiconductor, and insulator. It also fails to explain the positive value of Hall coefficient. According to this theory, only two electrons are present in the Fermi are responsible for conduction, which is not true. Thanks for watching.